What the A value affects is the width of the graph. It's kind of like the slope, because what did the slope affect of the line? What happens when you change that number? How it, can we have a word for it's not it's It's called the incline of the line. So it's how flat or how pitched the line is called the incline. This affects the width. So when A is greater than 1, you're going to get a skinny parabola. That's giants reefing on the top of it as hard as they can, yanking. It's called a vertical stretch. When 0 less than A less than 1, what the heck does that notation mean? Yeah, it means between. So remember this notation, the middle is just the English word between. When A is between 0 and 1, you get a really, really, really flat parabola. This is giants sitting on it, squishing it. It's called a vertical compression. What kind of numbers have we not talked about yet?
1, or negative.
Negatives.
So that's where it goes.
Okay, so when A is, how do I say negatives? Less than 0. What do you think happens? It flips over. I wrote greater. Duh. So this also affects the direction. That's what A does. Affects the width, affects the direction. Doesn't change the vertex. Well, it doesn't affect, it flips it over, but doesn't change its position. Doesn't really affect anything else. It's a width or it's a direction. P. Now, don't get too caught up in it being called P and Q. Just like this is M and B, they're always M and B. With a parabola, it really depends on the book. Sometimes they'll use H and K. Sometimes they'll use P and Q. I've seen B and C. Don't get too caught up in the actual variable itself. The P value is the x-coordinate of the vertex. What you don't need to know until next year is it's the x-coordinate because it's called a horizontal translation. And you've done translations way back in grade 9. You did translations, reflections, rotations. Do those words sound familiar? Yeah. Rotations was where you spin stuff. Reflections is where you flip it over side to side. What were translations? Who remembers? Just moving it. So this, what I'm doing is moving it horizontally. And if I move it horizontally, what happens to the vertex? The vertex moves with it. So that's why this affects the x-coordinate. It's called a horizontal translation. You don't need to know that for next year. The trick with this one is you have to change the sign. This is a little counterintuitive, and I'm not going to go into the why because it's about a 2-day lesson next year. You just have to believe me. When P is negative, so P is less than 0, it's actually moving to the right. Which I know seems weird because the negative numbers on the coordinate plane are on the left. You just have to trust me. If it's negative, it's actually moving to the right. And if P is greater than 0, it's moving to the left. And I'll explain how that's going to affect it when we get down to one of the questions. Well, if it changes the x-coordinate of the vertex, what else is going to change? The axis of symmetry. What else? Yes, the vertex is going to change, obviously. The vertex changed, therefore the axis of symmetry changes. Think about something moving side to side. What else is that going to affect? Is it going to affect the width? No. Is it going to affect it flipping over, so the direction? No. What else is it going to affect? The max and min, only if it's flipping, so not particularly. Is it going to affect the domain? But I got arrows and directions, right? What's the domain always going to be? Okay, so it's not going to affect that. What is it going to affect? Not the range, because that's the y. That's an up and down movement. What's the only thing left on the list that we haven't talked about? That's definitely going to change your x-intercepts and your y-intercept. Okay, so just keep.
We already said that.
Was that not brought up?
We already said that.
Damn it!
You're a little angry today. It's making me a little hostile. Okay, just keep that idea in mind and I'll come back to it. Q, again, don't get caught up in Q because sometimes they call it K, sometimes they call it C. If this one is the x coordinate, what do you think over here is going to happen?
Whoa.
You don't need to know until next year, but the reason it affects the y, it's called a vertical translation. So what you're doing is you're taking parabola and you're moving them up and down. That's why it's going to affect the y coordinate, because he's going higher or he's going lower. If I move something up and down, is it changing the width? Is it changing the direction? Is it changing the axis of symmetry? Is it changing the domain? No. Is it changing the x-intercepts? Yes. Is it going to change the y-intercepts? Is it going to change the max-min? Because it's going down. Is it going to change the max-min? Is it going to change the range? Yes. Keep that idea in mind. Do not change the sign. It'll mean more when we get down to an example with numbers, so I will come back to that thought. If Q is less than 0, the parabola is moving down, which makes sense because the negative values are down on the coordinate plane. If Q is greater than 0, it is moving up. I think you probably meant to say please, maybe a little bit. There's a theory you need to know. Just keep all those ideas in your head. Let's look at the questions. We're doing the same 8 properties as we did on Monday. All we're doing it now is with an equation instead of a graph. We're still going to determine the vertex, the axis of symmetry, the maximum, the direction, the domain, the range, the x and y intercept. This is where you would grab paper, which I'm sure you already took out. Just for the first one, I'm going to go through these numbers and tell you what it's doing to the parabola. The negative way out front, that's what affects the direction. If you ever see a negative at the beginning, what it tells you is that it's going down. If you don't see a negative, we assume it's positive, and it's positive, it's going up. That's what that negative does. The minute it's out front, it's going down. The 2 is the vertical stretch. So this is the giant grabbing it and pulling it. So what this does is making it half as wide, or it's half as skinny. Double as skinny? No, that doesn't make sense. Half as skinny? That didn't make sense. It's skinnier.
Twice as skinny.
Twice as skinny, I think, makes it better. This 3 here is the horizontal translation, and this is moving 3 units to the left, which is counterintuitive because it seems like it should be to the right, but it's not. It's to the left. The negative 8 at the back is our vertical translation, so this is moving it 8 units down. I'm not going to do that every single time because you don't really need to know much of that. You need to a little bit of it, but not much. But I just wanted to show you for the first one, that's what these numbers are doing. That's why they're called transformations of quadratic functions. They're transforming it. the regular, normal parabola, what's called x squared, it's called the base parabola, looks like this. Its vertex is at 0, 0, its direction is up, it has what we call a standard width. What is happening because of this, it has flipped down, it has gotten skinnier, it has moved 3 units to the left, and it has moved 8 down. So here is roughly what our new parabola looks like. And I'm going to get into the graphing with you later on. I just want for the visual people to have a picture of what's happening. This flipped it down, this made it skinny, this moved it to the left, this moved it down. So this is where our new parabola is. That's why the vertex and the axis symmetry and the max min, all these things are changing because we physically changed the position of the graph. Here's how to get the vertex from an equation. I'm going to say this probably half a bajillion times between now and the end of the semester. Not as many times as how many times or how many ways is there to solve a quadratic. Like how many ways are there to solve a quadratic? 4. And what would those 4 ways be? I'm going to say this half as many times. When finding the vertex from the equation, take the number in brackets, change the sign. Take the number outside the brackets, leave it alone. Take the number inside the brackets and change the sign. Take the number outside the brackets and leave it alone. The vertex is going to be the 3 in brackets, except I'm changing the sign to be a negative. I'm taking the number at the end outside the brackets all by itself. I am not changing the sign. My new vertex is -3, -8. That's really all we need to get almost everything else. Can I get the axis of symmetry from that? Sure, it's got to be x equals -3.
So when we get one of these equations, we say that the parabola or domain is like this, the base one?
It always is, because if you take away all these numbers, you're left with x squared. I always go to direction next, because I like the direction in order to get the max min. If you don't, whatever, don't care. How do you tell the direction? You look in front. If there's a negative, it's down. If there's no negative, it's up. This one is down. Then I go back to max min. If it's down, do I have a max or do I have a min?
Max.
I have a max. Where do I get its values from? Its value from? From the vertex. So y has to equal -8. E is the domain. This is the freebie point. You're going to memorize it. It's always going to be the same until next year. What's the domain? If you like the other notation, you can use the other notation. Questions so far?
I'm kind of confused as to where the vertex came from.
It's the number inside the brackets, you change the sign. It's the number outside the brackets, you leave it alone. Because that's what we've done is we've moved it 3 to the left, 8 down. So what is that coordinate point going to be? -3, -8. Still with me so far? How I get the range without the diagram is I actually look at the little picture of the direction. And what I do is in my head, but I'm going to write it down for you guys, is I picture this little down parabola. And what I know is that the very bottom has to be -infinity because the arrow's pointing down. And what do I know about the top of the graph? Where does it have to be? It has to be the max, which is -8. So then I say to myself is how do I express all the numbers from -infinity to -8 in this notation? How do I say all the numbers from -infinity to -8? If I wanted to use the other notation, what would I write down? Exactly. So I get it just from the picture of what's going here. And I'll show you later on an up parabola how I do it. Are you with me so far? Just repeating. Vertex comes from the equation. Take the number in brackets, change the sign. Take the number at the end, leave it alone. Axis of symmetry matches the first coordinate of the vertex. The direction comes from the negative in front. If there's a negative, it points down. The max min, the max comes from the fact it's pointing down. The value comes from the y coordinate of the vertex. Domain is domain. And this I get from the picture. Because it's pointing down, I know it's going down to -infinity. From the max, I know it's going up to -8. How do I say those numbers? Y is less than or equal to -8. The y-intercept, I need to do a little bit of work. If I gave you y equals mx plus b, and I put numbers in it for m and b, and I said find the y-intercept, how would you do it? Put 0 for, but it's a y-intercept we're trying to find. Put 0 for x and solve for. So let's just write down that in case you forgot. Substitute 0 for x and solve for y. So going back to the equation, I'm leaving y. I have negative 2, open bracket, 0 plus 3 squared, and minus 8. This becomes bed mass. What do I do first? Brackets. What is 0 plus 3?
Exponent.
What is 3 squared?
9. Multiplication. Negative 18. 26, negative 26.
How do I express the answer for the y-intercept? 0, comma, negative 26. Is it somebody I want to talk to?
Yes.
Are you sure I want to talk?
No.
Oh, it's Mr. Radley. I always want to talk to Mr. Radley. Okay, let's ask him for a joke. You have to tell us a joke.
Well, I'll tell you about it.
So good time to review. What's the step number 1 for square root method? Isolate the squared. What do I do with the 8? Move them where?
Other side. Divide by -2.
No, there was no carrying of a 1.
Root both sides.
Oh,
It's imaginary.
oh. Can we take the square root of a negative number? What does that mean?
Doesn't exist.
There's no solution. What does it mean in terms of the x-intercepts?
X-axis.
There are none. We'll take a look at the little graph I showed you. Why does that make sense?
Oh, yeah.
It doesn't cross the x-axis.
It done did.
Questions so far?
Is there an easy way just for that?
If there was, I would have shown it to you because I'm all about easy ways. Yeah, it was just number 1. Now why don't we do number 2? Okay.
Thank you.
Because, you know, if we're going to cry, let's save it for something we really need to cry about. Like, this is not it. This really is not cryable. I'm going to go vertically this time, just for fun. Take the number in brackets, change the sign. Take the number outside brackets, leave it alone. I don't have any brackets. Yeah, well, there are brackets. What number am I adding to x if there's really no brackets? It's plus 0, that's all that means. So what's the x coordinate of the vertex? So if there's no number in brackets, it's 0. If there's no number at the end, it's 0. Write down the axis of symmetry. Tell me what to write down. Oh, I don't want to lose a half mark. I skip C, I go to D, I do the direction first. What's the direction and how do we know? How do I know that it's down? Okay, because it's down, what do I have up here for C? What do I write down after that? E, domain. Range, I go back to the picture that I have pointing down. Down means that the lowest value is going to be negative infinity. What's the highest value? 2. How do I say all the numbers from negative infinity to 2? Or? Questions so far? How much work was involved with that? Not a lot. These are the two you got to work for. So y-intercept first. And y-intercept is where we set x equal to 0. -2. Wait. But I said you can't just look at it and find out what the x-intercept is, or the y-intercept. Yes, sometimes you can. Generally, you can't. So don't get in the habit of just thinking this number is the x or y-intercept. How do I state the y-intercept down here? Okay, x-intercept. That's where we put y equal to 0. You can use any method you want. I don't care. I use square root because it's easiest. Okay, what do we do first? Okay, get the 2 to the other side. Ooh, not yet.
Divide by negatives.
Oh, positive, negative. Lottie blew that on the test yesterday.
Positive, negative. Wouldn't it be negative?
It could be either.
Could it?
Yeah.
How?
That's how roots go. Just how roots work. Just how they go.
How, though?
Because when two negatives multiply, they can make positive 2, so it could, square root of 9 could either be negative 3 times negative 3 equals positive 9.
But it's root negative 2.
No, we got rid of that with when we divided by negatives.
But, yes, we did. Yes, we did do that, but wouldn't that make the 2 negative?
It was already negative.
No, it wasn't.
It
Yeah,
was.
it was, because you had to take 2 away from each side.
Damn it! Taunt you, Caitlin.
How do I give the answer?
Oh,
Negative 2 comma 0.
Close.
And then you just list, oh, you list 2. And then I'll shoot.
yes.
Could you just list it as like plus minus for 2? Or do you have to say plus? You have to say plus?
Because there's coordinate points. Questions so far?
I'm gonna go this with that.
Oh, it goes up. Oh, okay.
Yeah, if you make a decimal, it actually helps make it not look so bad.
Why did you get the right brain this time?
I don't like that at all.
So it's like marking some of your tests. Except H would be up here, and then there'd be an arrow over here, and G might be on the back. Vertex, take the number in brackets, change the sign. Take the number at the end, leave it alone. Write down the vertex. Don't say it, write it down. Peek over at someone, not in a creepy way, in a friendly way. Check their vertex. If you have the same vertex, you high-five them. What should you write down?
Bracket 1 and 2.
Write down the axis of symmetry. Write down the axis of symmetry. What would you like me to write down? I go to direction. If you like to do C next, you do C next. I go to D. What's the direction? Draw it.
It's just the sign, right? Not 5 times 0.5?
What should I draw?
Happy fun.
Write down whether it's a max or min and state the value. Offer of min y equals 2.
Yep.
Write down the domain. I'll show you how my brain goes through the range when it's pointing up. When I have arrows pointing up, I know the highest value is infinity. Then I go down to the min and I know it's 2. How do I say all the values from 2 to infinity?
Y is greater than or equal to 2.
Y-intercept, well, it's got to be 2 because that's the end of the equation, though clearly it's... What? What do you mean no? What? How do I find a y-intercept? Yes.
To do the stuff.
Yes. What kind of surf? The steps.
Substitute x for 0 and then perform the complete the square method. Or square root method, I mean. Wait, what? No, bed mass. Square root is the other thing. So one thing I want to I learned from this class is not to deny.
One.
0 minus 1.
-1.
-1 squared.
1.
1 times a half.
Half.
Half plus 2.
2.5.
2.5. If you wanted as fraction, I would accept. If we wanted it as a fraction,
Oh, 2.5.
is a decimal. If I wanted it as a fraction.
Oh, you can't have it a mixed.
You can. Well, no, we wouldn't do mixed. 5/2. I'm a little scared nobody said that. How do we find the x-intercepts?
Wait, was that rhetorical?
No, I was kind of waiting for a fill in the blank there.
Well,
But.
then in that case, now you substitute y for 0, and now you do the square root method. Hey, look at that. Hey, look at that. It takes for significantly more than that.
What do you want to do first? Now what? So you can divide by the half. What I do is just worry about the 2 on the bottom. What's the opposite of dividing something by 2? Timesing by 2, so I'm going to get -4. It's just the short way to do it. Make a conclusion, don't just leave it. So what does this mean in terms of x-intercepts? There are none. Just leaving it tells me you didn't know what to do, you didn't know how to solve it, you didn't know what was going on, right? The word none, N-A, aren't any, don't exist.
Whatever gets the message across.
You could tell that through the max, min, and the direction.
Then you would explain that in words. Questions?
On a question on a test, you would have to show you
Nope.
trying it.
You can show it by explaining it. Now, turn in your package to the back of the first sheet that we worked on last class. You're going to find a mysterious table